Last time we said the definition of pi was the ratio of the circumference of a circle to its diameter, and we derived that the circumference of a circle was 2 pi r, and we also derived that the area of a circle was pi r squared, like so. And we also derived that the surface area of a side or cylinder was 2 pi r times h. If we say that the height of the cylinder is twice of the radius of the base circle, then we could say that the surface area of the surface area of the side of the cylinder is 2 pi r times 2r, which is equal to 4 pi r squared. Okay. Now, let's say that we have a sphere that's enclosed by a cylinder, like so. If we cut the cylinder along with the circle, like so, we have strips. And let's concentrate on the surface area of the strip of the cylinder. If you look, and then if you spread out it like this, and each strip of the cylinder will look something like this. And let's look at the surface area of the piece of the sphere that's cut like this. And for this top part, we're gonna see something like this. And for the second part, we have a little bit longer strip, but thinner strip. For this one, it's gonna be longer, but even thinner. But what you're gonna get is that although the strip here is longer, widthwise, it's shorter in the lengthwise. So in total surface area of the strip of a sphere is gonna equal to the surface area of the strip of the side wall of the cylinder. So therefore, what we are going to say is that surface area of the side of the cylinder is equal to the surface area of a sphere that's enclosed by this cylinder. So what we are going to see is that the surface area of a cylinder is equal to surface area of a sphere. So let's calculate the surface area cylinder. of a side of the cylinder. We derive that equation here. We said surface area of a side of the cylinder is equal to 4 pi r squared. So there you have it, 4 pi r squared. Now let's try to find the volume of a sphere. The way we approach how to derive the equation for the volume of a sphere is to look at the sphere once again that's enclosed by a cylinder, like so. Let's cut the cylinder along with the sphere in half. If we cut it and look at the half of the cylinder and the hemisphere of a sphere, and let's imagine that we are subtracting this half of a cylinder, saying minus the hemisphere of a sphere is gonna equal to cone this upside down. And what you're gonna get is that, let's say if as a whole half of the cylinder is 1, then and this is the same as saying we are subtracting this half of a cylinder minus this upside down cone equal to hemisphere of the sphere. And if we say this entire cylinder is 1, this cone, the volume of the cone is equivalent to 1/3 of the sphere, the cylinder. Then this volume of the sphere is going to be 2/3 of this cylinder. So we could say that the volume of a sphere is equal to 2/3 of volume of a cylinder. So we said volume of a cylinder was pi r squared times height. And if we say the height of a cylinder is h, then his h is equal to 2r because of the sphere has radius r, like so. So it's gonna be 2/3 pi r squared times 2r, which is equal to 4 thirds pi r cube. So the volume of a sphere is equal to 4 thirds pi r cube. And volume of a cylinder that encloses a sphere is pi r h is equal to pi r squared times 2r, which is equal to the cylinder is 2 pi r cube. So there you have it. Thank you.